Hi, my name is HAZWINA BINTI HAIRULAZIZE. My matrix number is 2025403538 and I am the leader of this group.
Hi, Assalamualaikum. My name is NURUL NABIHAH ROZAIDI. My matrix number is 20254050442 and I am one of this group members.
Hello, my name is SYAZANA SURIA and my matric number is 2025293986 and I'm one of the member of this group.
My name is YASMIN binti ROSLI and my matrix number is 2025401842. I'm one of the member in this group.
Now I will explain the first question from part A. Please pause the video if you want to read the question. Now, based on the question, there is a compound interest problem where the interest rate and compounded frequency change over the investment period. The problem we have to find is accumulated amount at 16 October 2019. Firstly, we need to understand the compound interest formula and important terms. Now, let's answer this question. Firstly, I advise you to draw a timelines so we can understand more better the flow of this question. Based on these timelines, we have three important dates, which are 16 April 2016, 16 April 2018, and the last one is 16 October 2019. So we have to calculate at the first phase, which is 16 April 2016 until 16 April 2018. From there, we can know that the time is 2 years. So we have to calculate with compound interest formula, which is S equal to P multiply 1 plus I power N. So we continue with 7,500 multiply 1 plus 0.01 power 12. And we got the answer is 8,451 ringgit 19 cents. But it's not done yet. We have to calculate on the next phase, which is at 16 April 2018 until 16 October 2019. From there, we can know that the time is 1.5 years or 1 year 6 months. And now we have to use the same formula, which is S equal to P multiply 1 plus I power N. And we have to continue with 8451.19 multiply 1 plus 0.02 power 6. And finally, we got the final answer, which is 9,570 ringgit 41 cents. So that is the amount accumulated on 16 October 2019.
For question 2, we need to decide which bank Mr. Daniel should invest in for 3 years and justify our choice by comparing the final results from both banks. First, let's look at Alpha Banks. Alpha Bank compounds interest every 4 months, which means 3 times a year. So for 3 years, the total number of compounding periods is 9. The periodic interest rate is the annual rate of 4.35% divided by 3, which is 0.0145. Using the compound interest formula, S equal P 1 plus I power N, where P is 58,000, I is 0.0145, and N is 9. The final amount for Alpha Bank is 66,02318. Next, we compare this to Omega Bank. Omega Bank compounds interest monthly, which is 12 times a year. So for 3 years, the total number of periods is 36. The periodic interest rate is 0.0450 divided by 12. Using the same formula, S equal P 1 plus I power N, with P is 58,000, I is 0.0450 divided by 12, and also N is 36. The final amount for Omega Bank is 66,366.37. When we compare both results, Omega Bank gives a higher return. This is because Omega Bank compounds more frequently and produce a larger final amount. The difference between the two banks is 343.19. Therefore, the better option for Mr. Daniel is Omega Bank, as it provides a higher effective return after 3 years. For part B, we need to find the amount left in Mr. Daniel's account after 6 years. Given that he withdraws 15,000 at the end of the 4th year, we continue using Omega Bank because it was the recommended bank in part A. First, we calculate the amount after 4 years. In Omega Bank compounds interest monthly, which is 12 times per year. So for 4 years, the total number of compounding periods is 48. The periodic interest rate remains the same as before, which is 0.0450 divided by 12. Using the formula S equal P 1 plus I power N, with P 58,000, I equal 0.0450 divided by 12, and for N is 48. The total amount after 4 years is 69,415.37. 0.23. Next, Mr. Daniels withdraws 15,000 from this amount. So the remaining balance becomes 54,415,000.23. This is because 69,415.23 minus 15,000. Now we let this remaining balance continue earning interest for another 2 years. 2 years of monthly compounding means 24 periods. Again, using the same formula, S equal P1 plus I power N. P is 54,415,000.23. I equal 0.0450 divided by 12. And for N is 24. The final amount after 6 years becomes RM 59,529.72. So the amount left in Mr. Daniel's account at the end of 6 years is RM 59,529,000.72.
Next, we move to part B, question number 1. You can pause this slide if you want to read the question. First of all, we need to know which chapter is this question is based on a keyword given. The keyword given in this question is scholarship payouts. We know that a scholarship will be paid at the same time and the same amount. So obviously, this is a chapter 4 of business mathematics, which is annuity. Annuity is a series of usual equal payment made at equal interval of time. First of all, for this question, we need to identify first, is it a future value or present value? But for the question A, it is a present value because of a deposit now as a keyword. From the question, they have some important information such as I equal 3.8% over 2, which is 0.019, and 2 multiplied by 10, which is 20, and R 5,500. We will use the formula of A equal R 1 minus 1 plus I power negative n over I. We substitute all the information that we have and we can get the value of A. Lastly, the value of A equals to 90,806 ringgit 83 cents. For this question B, we will use future value of annuity because of the equal monthly deposits as a keyword for this question. They have some important information that give from the question, which is I equals 2.5% over 12, and 12 multiplied by 4 is 48, and S equal 90806.83, which is the answer from the question 1A. So we will use the formula S equal R 1 plus I power n minus 1 over I. We substitute all the information that we have and we can search for the R value. Lastly, the R value is equal for 1,800 ringgit 76 cents.
So we move to question 2. Please pause the video if you want to read the question. For part A, first I calculated the amount financed. He only borrowed 70% of RM29550, which is 70% multiplied with 29550 equal 20685. Next, I found monthly interest, which is I. Annual rate is 6.7%, so the monthly rate is 0.067 divided 12. Then I calculated the number of monthly payments, which is N. 5 years multiplied with 12 equals 16. I use installment formula, which is A equal R bracket 1 minus in bracket 1 plus I close bracket power of N divided I close bracket. 20685 equal R bracket 1 minus in bracket 1 plus 0.067 divided 12 close bracket power of 60 divided 0.067 divided 12 close bracket. After substituting the values and solving for R, the monthly payment is RM406.67 per month. Next, I calculated the total interest paid. The formula is I equal bracket R multiply N close bracket minus 8. So I equal bracket 406.67 multiply 16 close bracket minus 20685 equal RM3715.20. So the total interest he will pay over 5 years is RM3715.20. In this part, Mr. Adi missed some payments. The bank said he owes RM2894.82, including interest. I used the Aries formula, which is S equal R bracket in bracket 1 plus I close bracket power of N minus 1 divided by I close bracket. So here is 2894.82 equal 406.67 bracket in bracket 1 plus 0.067 divide 12 close bracket power of N minus 1 divided 0.067 divided by 12 close bracket. I simplified the equation, then used log to solve for N. The answer I got was N equals 6.99, which is approximately 7 months. So Mr. Adi has made 7 monthly payments.